Welcome, everyone. My name is Boglarka Bojogi. I'm Research and Innovation Officer at IFAM Organics Europe, and I work with the Intercrop Values Project. And it is my pleasure to welcome you all to this webinar this morning with the title Cultivating Species Mixtures is a Viable Option, but only with adapted agricultural equipment. So we will be talking about machinery specific for intercropping. And the Intercrop Values Project, per se, stands for Developing Intercropping for Agri-Food Value Chains and Ecosystem Services Delivery in Europe and Southern countries. We are a Horizon Europe project that lasts for 4 years. This is the last year of the project where we're sharing most of our results from the scientific processes, and the project is coordinated by CIRAD in France. Intercropping, also known as species mixtures, means the cultivation of multiple species in the same field at the same time. And this can have a lot of benefits, including improved resource use or yield stability, robustness, soil health improvements, economic diversification on the farm. But despite these well-documented advantages, farmers are still facing a lot of obstacles to implement intercropping, which can be technical, organizational, or economic along the value chain. So that's why the Intercrop Values Project tries to exploit the benefits of intercropping to design and manage productive, diversified, resilient, profitable, and environmentally friendly cropping systems that are acceptable to farmers and actors along the agri-food system. They're a multidisciplinary, multi-actor project with 27 participants from 15 countries across 3 continents. You can see the partner organizations on the slide. And we have a lot of interesting outputs that could be valuable for you if you're here today, including some practice abstracts, some of which are already available on our website at intercropvalues.eu. And some of them are still to come in the coming months. The policy briefs as well, with some policy recommendations. Some of them are already published and some of them are yet to come. We're organizing a whole range of events on the field here in Brussels, scientific and policy conferences. We're publishing videos to share the results, infographics, and articles. And particularly, one interesting result could be a brochure on the guidelines for innovative machinery for sowing, weeding, harvesting, cleaning, and sorting, which is the key output that will come from this project, but also from the Remix project, which is a completed project that this one builds on. We have some published guidelines on the theory and practice of species mixtures that is available in English and French on our website. So to go a little bit more in detail about the project, we support local innovative value chains through 13 co-innovation case studies, or KICs, on the field, mostly in Europe, but also in Mozambique and La Réunion. We conduct 15 meta-experiments to understand plant-plant interactions in intercropping. We try to generate knowledge methods and tools for the management of intercrops. We use modeling to understand intercropping performance. We have a whole work package on quality of grains harvested and how to process cereal legume intercrops. And then we try to delve into the barriers and levers at the value chain to boost the agroecological transition through the use of intercropping in Europe. And just to remind you that this webinar is the first one of a 3-part series. So this one is focused on machinery. The next one on February 26th from 11 to 12:30 will focus more from a farmer perspective and discuss how intercropping can improve soil health and how to use indicators to tell that. And then the last one will focus on processing intercrop cereals and legumes following the process from field to food. This will take place on March 2 from 2 to 3:30. But so today we have an impressive series of 4 presentations, and then there will be plenty of time for discussion, questions for you to engage with the speakers. First, we will start with an introduction to species mixtures, their definition, and the diversity of the practice and interest for farmers by Laurent Bedussac, professor at ENSFEA, and Chloé Salambier, research fellow at INRAE. Then we will go into strategies regarding agro-equipment to overcome intercropping barriers by Céline Chevalier, research fellow at UC Louvain, Team Citra. Then Esther Fouillet, research fellow at INRAE, and Hadrian Pam, PhD at INRAE, will give a presentation on farmers' agro-equipment park design for transition. And finally, we'll see some concrete illustrations from the field from co-innovation case studies by Fanny Rau, research engineer at INRAE, Margot Leclerc, research fellow at INRAE, and Lene Koolmorgen, former intern at INRAE. So without further ado, I'll give the word to Laurent. Thank you.
Thank you very much, Bogi, for your introduction. So the jump into species mixture that you already defined, it can be seen as a very traditional practice since Maya were already growing species mixture. And this practice is more or less widespread and covers a diversity of systems, major crops, but also agroforestry, intercropping in a orchard for vegetable production or in vineyard, but we are going to focus on large crops. So intercropping is an application of ecological principles with the aim to enhance natural resources, but also to regulate biotic factors. So when we are mixing two species, first they are competing because they each one want to produce grains or vegetation. And there is what we call competition. And when this competition is more or less greater, when the species is more competitive than the other one. So for example, when we are mixing cereal and the legumes, there is a competition for soil mineral nitrogen, and often the cereal is more competitive, so is more successful in taking the mineral nitrogen from the soil compared to the legume. But the interest of mixing a cereal and the legume is that the legume has the ability to fix nitrogen from the air. So there is a complementarity between the two species because they don't have the same requirements for nitrogen, but also for other resources like water, phosphorus, potassium, and others. Be aware that when there is no direct transfer of nitrogen between the species in a cereal legumes mixture. There is other processes such as cooperation. It's when the modification of the environment by one species is beneficial to the other. It is the case, for example, in wheat-lentil intercropping with the wheat preventing the lodging of the lentil. And there is also compensation, is when the failure of one species is compensated by the others because it is less sensitive to abiotic or biotic stresses. When we take a broad view of the interest of cereal legumes intercrops regarding yield and grain protein content, so this is an experiment carried out during 10 years in through 2 different countries with a very large diversity of mixtures, we saw that often the total grain yield of the intercrop is higher than the mean of the soil crop. So there is an interest for farmer to grow mixture because he will produce more grains. And similarly, we have an increase in the grain protein content of the cereal compared when it is intercropped with legume compared to the cereal cultivated alone in the same conditions. Intercropping can also be seen as a kind of precision agriculture. Here is 4 pictures. It is the same mixture that has been sown by a farmer in the southwest of France. The same day, so same composition, pea and barley, but on 4 different fields with different soil structures, soil nutrient content as the previous crop. And we see that the composition of the mixture is then depending on these previous crops. And in some cases, at the right, there is a lot of nitrogen because the intercrop was being sown after grassland, so with a lot of nitrogen. And in this case, most of the pea has disappeared. And perhaps in this situation, the farmer should have not grow a species mixture, but better only a cereal. So intercropping is only a tool that must be used, but not always depending on the conditions. Regarding pest control, when we make a literature review, we see that usually there is a benefit of mixing species regarding weeds control. Similarly, for diseases and also often for pests, sometimes there is no effects, and in a very limited amount of research, we saw that there is a negative effect of species mixture, so it means an increase in weeds or disease of pests. This doesn't mean that intercropping is able to control all kinds of weeds, all kinds of disease, all kinds of pests, and it requires a very deep understanding of the pest bioecology in order to design an adapted species mixture aiming at control specific weeds, disease, or pests. Now, the idea was to show that farmers are very innovative. When we look at research work done on species mixture, so that researchers worked on a very limited number of species combination, while farmers grow very large diversity. Here it's a survey that has been carried out on 47 farmers in France, showing they are growing 77 different mixtures, considering the kind of species, and altogether they are combining 29 different species. And they also produce species mixture for food, for feed, for fodder, and sometimes for ecosystem services. Similarly, farmers are very innovative. They not only grow species mixture sown and harvested at the same time, which is the common practice. Sometimes they grow cereal. For example, here it's a rapeseed with legumes that disappear during the growth of the rapeseeds. Sometimes they sow an alfalfa into a wheat or wheat into an alfalfa, sometimes relay cropping, sometimes semi-permanent cover crop, relay cover crop that becomes a crop. So a very large diversity of practices, and we will see later that it will have consequences on the kind of requirements for machinery for sowing and harvesting. As Bogi indicated before, in a previous European project Remix, we try to formalize farmers' practices in order to help others. So this brochure is available online, and you can find on it 52 different species mixtures that are being grown by farmers, and for many different purposes. For example, a grassland risk insurance. These are farmers that cultivate species mixtures with a meadow, with the aim of implementing a meadow first. Other is for very classical for animal feeding, which is a barley pea mixtures. Other mixture for high quality wheat with an adjuvant, such as wheat and faba bean, and others for securing grain legume production, here lentil mixed with wheat. When we ask farmers what is their perception and interest when growing a species mixture, we find results that confirm what literature is indicated. Mostly it's for weed and disease control, but also when they introduce legume in the mixtures with the aim of reducing nitrogen fertilizer and also stabilize, increase yield, feed autonomy for livestock, reduce and simplify their work, and also because they have interest for innovation. Conversely, they sometimes reveal some limits, and the main limit, and what is the interest of our talk today, is how to harvest and separate in order then to be able to commercialize species mixtures. And this is far away the main limits they are identifying. Even so, they are also identifying some limits regarding sowing, disease, also because they have a lack of experience. So that's why we decided to make this specific work on machine. My colleagues will go more precisely in details, but what is very important is we want to increase the economic performance of species mixtures. We have to know how to sort mixtures. It is not necessarily an easy task. It needs different kind of materials, time, and competencies. And to be able to separate the mixture, First, we have to harvest properly, because if there is too many broken grains or impurities, then the separation part is more difficult. And this has been evaluated in the previous Remix project, showing that combiners are quite efficient, but still farmers need competencies on how to optimize the setting of this equipment, because it is not possible to develop specific combine harvester because of their cost. My last slide is just to remind that species mixture are only one part of diversification. Diversification can be done by varietal mixtures, agroforestry, rotation, but also at the landscape scales. And if we want to move to an agroecological transition, we need to combine all these different aspects. So it's only one part of diversification. And there is several works that has been done by Vialat and al. Or Belouin and al. Showing that the impact of crop diversification is when we combine different strategies at the same time in order to have a highest pest and disease control, to improve water quality, water regulation, greenhouse gases emission. So even if our talk today will be focused on species mixtures, remember that it's only one part of the solution, one solution among others, but it's not able to do everything. So now I will give the floor to my colleagues. Céline, the floor is yours.
Thank you, Laurent. So my name is Céline Chevalier, and I'm a research fellow at the ICV University in Belgium, and I work in a team called CITRA, in which we mainly focus on the analysis of the sustainable transition of agri-food system. And so today I'm going to talk to you about strategies regarding agro-equipment to overcome intercropping barriers. We can move on to the next slide. Thank you. So as Laurent and Bogi said, there are different obstacles that are faced by farmers and also by other actors of the value chain when using crops coming from intercropping and intercropping in the field. And if we want to foster the use of intercropping in Europe, we need to understand what are these obstacles. So this is what we did in the Intercrop Values project. We did what we call the barrier analysis. A barrier can be defined as a specific obstacle to the adoption of an innovative practice or innovative strategies. So in this case, intercropping. And the accumulation of barriers and their interaction really locks the system in its current states and prevents it from moving to a more sustainable state, and so prevents actors from adopting more sustainable agricultural practices. We can move on to the next. Thank you. So in the Intercrop Values project, we did this analysis based on the case study that Bogi shortly presented to you at the beginning of this webinar. The case study are really groups of actors aiming at developing intercropping-based value chains, and they cover a broad range of contexts, a broad range of value chain types, of intercropping types, and so on. So we have quite an exhaustive identification of barriers, and we identified about 200 barriers to the use of intercropping. What you can see here on the figure is that what is interesting is that all the different levels of the value chain are affected by at least some barriers. So intercropping may seem to be a very farm-related issue, but in fact, it's also linked to barriers at different levels of the value chain, including processors, collectors, and so on. However, you can also see that the farm level is still the level of the value chain that is affected by the highest number of barriers. You can move on to the next one. Yeah, thank you. What we also saw in the analysis is that there are a lot of different types of barriers that are preventing the use of intercropping in Europe, such as financial ones, for example, the high price for intercropping products for consumers, cultural barriers, such as the fear of yield decrease, some organizational ones, difficulty in scaling up intercropping practices, and so on. And also technical barriers, such as the risk of contamination with allergens, but also barriers linked to the agri-equipment. So agri-equipment remain a very important issue in adopting intercropping. You can move on to the next one. And so regarding agri-equipments, we identified several barriers at the farm level and at collector level. So at the farm level, actors mentioned barriers linked to agri-equipment for sowing, crop management, and harvest. These barriers are mostly linked to the lack of suitable machinery, sowing machinery, harvesting machinery, weeding machinery for intercropping. There are also some issues linked to the need for multi-step sowing or multi-step harvesting, because as the machinery is not well suited to sow or to harvest two crops at the same time, sometimes you have to go twice and seed the crops separately. And all these barriers could be overcome with the development of suitable machinery, such as two-tank seeders or combine harvester that allow for a modification of harvesting settings on the go, or the development of weeding machinery that could cope with intercropping and with two different crops being sown at the same time. And by developing this new machinery, we tackled some technical barriers, but we also tackled some organizational barriers, such as the additional workload or the increased work arduousness that are linked to the fact that we don't have suitable machinery and that we may add some additional steps, or that we may need to do some manual weeding in the field, for example. You can move on to the next slide. At collectors level, the main issue is linked to crop sorting, because there is some technical barriers, such as the inadequacy of current sorting and storage lines, the lack of suitable sorting machinery, the risk of grain breakages at harvest, and so on. And these barriers are also linked to financial barriers. For example, the additional costs linked to the additional sorting step that we need to go through to have some a good level of purity in crops coming from intercropping, and organizational barrier linked to the additional sorting step and the additional workload that it leads to. Again, several solutions exist to overcome these barriers, such as adapting the harvesting settings to minimize grain breakages, which is also linked to the fact that we have developing some suitable combined harvester, adapting the sorting lines, for example, using more adapted sieves, using band conveyors instead of screw ones to minimize grain breakages, develop mobile sorting facilities, and so on. So we already have a lot of different ideas on how to overcome these barriers. You can move on to the next one. And what is interesting to see in those examples and in the different solutions that were proposed by the actors in the Intercrop Valleys projects is that we can act on the lack of adapted agri-equipment in different ways. We can, of course, develop new equipment that is adapted to intercropping, but we can also work on improving the access to existing equipment, for example, by creating equipment sharing groups, by developing some mobile sorting facilities, by spreading existing innovations, because, for example, there was this idea of developing two-tank seeders that was mentioned by some actors, but other actors are saying, okay, but it already exists, but maybe it's not very well spread across all countries, across all Europe, and so on. And we could also support the investment in equipment, either new or second-hand in equipment suitable for intercropping. And we could also work on adapting the current equipment that is currently available to the farmers that they currently have in their farms. And these different strategies to act on the lack of adapted agri-equipment rely on the involvement of different actors. So for the development of new equipment, it will mostly rely on the involvement of agri-equipment developers. Improving the access, we rely mostly on farmers and collectors, and maybe also institutions to organize machinery sharing groups. We rely on agri-equipment developers to develop some mobile sorting facilities, on agricultural advisors to help spreading innovations that currently exist, and on also politics to support the investment in machinery. And the adaptation of existing equipment will rely on farmers and agricultural advisors mostly. You can move on to the next one. So you can see that agri-equipment is really an important issue to tackle to foster the use of intercropping. But what is also really important to understand is that the different barriers preventing the use of intercropping really make up a complex system. They interact with one another and they can lead to some reinforcing feedback loops. So here is an example of a map of barriers that we did. It's not important to go through all the map, but what we can see, for example, is that the lack of adapted equipment and lack of adapted harvesting and sorting equipment lead to the presence of impurities in the crops coming from intercropping. So these crops are incompatible with the quality standards expected from processors, mostly for when the crops are dedicated to food. So there is a lack of value chain acceptance of intercropping and a lack of valorization, because sometimes crops coming from intercropping that are dedicated to food are downgraded to feed. And so, of course, this leads to a lack of profitability for the farmers. So the farmers face some high risks and some fears, and so they won't be willing to use intercropping, and they won't be willing to invest in adapted equipment. So there is kind of negative reinforcing feedback loops. You can move on to the next slide. So overcoming this intercropping lock-in, we really require acting simultaneously on different leverage points, on different parts of the system to really foster change. And agri-equipment is only one of these leverage points. You can move on to the next one. And what is important to understand is that the success of acting on agri-equipment to really foster the use of intercropping will also depend on actions undertaken on other leverage points. So if we go back to the different strategies to act on agri-equipment, and if you take the strategies to develop new equipment adapted to intercropping, you can see that these strategies will require working on knowledge and experience, because we need to generate knowledge about what is required in terms of equipment and in terms of settings for developing machinery that is suitable for intercropping. And we also need to work on market securing awareness and political support to really foster the use of intercropping and really incentivize farmers to use intercropping by ensuring them that intercropping crops will be accepted by downstream actors, by raising their awareness about the different benefits of intercropping, by supporting the investment of equipment suitable for intercropping and so on, so that we can also secure a market for these new IC adapted, intercropping adapted equipment that will be developed. So just acting on agri-equipment alone is not enough. And in addition, the relevance and the way we will act on the lack of adapted agri-equipment for intercropping will also depend on the overall strategy that we have for the development of intercropping and on the vision we have for the future of intercropping. So we can take really two really contrasted strategies for the development of intercropping. On one hand, we could really try to minimize the impurity level in harvested intercrop and really try to store them so that the crops coming from intercropping could be processed in the same value chains as the crop coming from pure crops, and so that there won't be any difference between the two. And in this case, we really need to invest a lot in developing harvesting and sorting machinery that are really efficient for dealing with intercropping and preventing grain breakages and so on, to reach the impurity threshold that are expected by the processors. But if we take another strategy in which we would like mostly to valorize intercropping in maybe shorter value chains, in which the impurity threshold may be more flexible, or in which we would like to really valorize the impurities coming from intercropping by making, for example, some wheat chickpea bread and so on. In this case, we don't need to invest as much in the development of sorting facilities, because current sorting facilities already are efficient enough to reach some quite acceptable impurity threshold if we want to be a bit more flexible. So the way we will distribute the resources to develop some agri-equipment adapted to intercropping will really depend on the overall strategies we have for intercropping. So now you can move on to the next one. So just to conclude this short presentation, 3 main take-home messages. The first one is that appropriate agri-equipment is really key for the development of intercropping in Europe, because a lot of different barriers are linked to this lack of adapted equipment. The second one is that acting on appropriate agri-equipment is not limited only to developing new equipment. We should also invest some resources in improving the access to existing equipment and adapting current agri-equipment. And last but not least, the strategies related to the agri-equipment and adapted agri-equipment for intercropping must be thought in coordination with strategies to address other leverage points, and will also need to be thought keeping in mind the overall strategies we have for the development of intercropping in Europe. So that's
Thank you,
all.
Céline. Thank you, Céline. So now we will move to a presentation of Esther and Adrien. So the floor is yours.
Thank you, Laurent. So we are Adrien and Esther from INRAE, and we are going to talk about farmers' agri-equipment park designed for transition. So Laurent, can you? Yes, thanks. So as Céline just showed, access to adapted machinery is often presented as a barrier to crop diversification and species mixtures development for several reasons, because the existing machineries can be inappropriate to local uses, the cost can be dissuasive, and the maintenance of machineries can be high. And few studies have examined how farmers have appropriated and developed species mixtures practices over time. So questions arise about how farmers manage their equipment to be able to implement species mixtures, which is unknown today.
So beyond the scientific question, these results also matter for action, and in particular, this study can support the work of the FN-CUMA, our partner. Quickly, the FN-CUMA is a network of cooperatives for the use of agricultural machinery, and it allows farmers to share cost on and sometimes share operation like linked to agricultural machinery. And the CUMA network is an important actor in French agriculture since it brings together more than 200,000 members. So this study can help inform and support farmers who are motivated to appropriate crop mixtures. And it can also provide keys to support the management of agri-equipment in order to develop mixture in diverse situations, and you will see that. You can move to the next slide. Thank you.
So two different studies were conducted. So my work focused on how farmers manage their agro-equipment to grow and sort species mixtures. So to do so, we tracked on-farm innovation with a focus on machineries. That means that we conducted interviews with farmers that we identified that had modified, tinkered, repurposed their equipment to grow and sort species mixtures. And the aim of the interviews were to investigate how they manage their equipment fleet, with first analyze the technical itinerary implemented for each species mixtures, the equipment it requires, and we recontextualize this technical itinerary in the farmer's action situation. And we were able to identify so the farmer's action logic with like what are the machineries and what they are used for, in which condition, for which kind of mixtures and value chain, etc. And then Adrien conducted another work that you will present, the methods.
Yes, so what interested us in this work is a dynamic analysis over the long term of the practice of species mixture and the equipment of transformation made by the farmer. So it's really this co-evolution between the practice and the equipment that we were interested in. So to do that, we used a trajectory approach in line with Moulin and Tofoloni et al. So we used the same concept of logic of action that Esther explained just before. And we also use concepts from design theory to analyze what happened at the equipment level. And the figure on the left shows a typical trajectory. So it shows the coevolution between the equipment used and the species mixture. So how they are cultivated, how they evolve, and the reasoning behind them, which are embodied by the little clouds. Thank you. You can move to the next slide.
Yes.
Sorry.
So we try to combine our results. So the first results that we had, it's that during interviews, farmers emphasized that sowing was a key moment during which they adapted their machinery. So one of the first results was to characterize the species mixtures through the lens of equipment and sowing. So our analysis of the species mixtures sheds light on sowing characteristics linked to spatial arrangement. So as you can see, we did a typology and we identified 6 types. The first characteristics was the spatial arrangements. So it was if the farmers were sowing species in alternating row, so type 2 and 5, or in the same row, type 1 and 4, or with one species sown at least broadcasts. Yeah, thank you, Laurent. 3 and 6. And the other characteristics was the depth. So if the species were sown at the same depth, so type 1 to 3, or at different depths, 4, 5, 6. And that one result we show that it was that there were no specific spatial arrangement type for species mixture. So for example, on the 14 farmers interviewed, we identified that faba bean was sown in 5 of the 6 types. So it depends on the machinery they had, the objectives, and the objectives they had. So you can move to the next, yeah.
So the second result is that when farmer grow species mixture, there is a wide range of possible technical operation across the whole cropping cycle. And this is true for sowing, weeding, harvesting, and sorting. But there are many kinds of adjustment in practice, but most of them mainly concern sowing and sorting. You can move to the next slide. So what we showed is that there is a diversity of transformation, what I said, carried out on the equipment to adapt practices to the cultivation of species mixture. And as you can see, we classified the equipment design activity in 2 categories. First, activities that concern the farm machinery system level. So we find buying a machine, which is maybe the most obvious activity, selling, service provision, using a new combination of equipment, and self-construction. The second category concerns the equipment itself. So here we are reproposing, modifying the physical structure of the equipment. And of course, these activities are often combined and support the evolution of the mixture practice. For example, sowing a new species, developing new sowing methods, or valuing mixture through sorting and development of alternative marketing channel.
So now I will give you some example of equipment modified, tinkered, we identified during the interviews. So the first example is a tinkered no-till seed drill that was tinkered to sow 2 species in one pass at different depths to sow the wheat faba bean mixtures. So what the farmers did he modified his no-till drill. Originally, with 2 distribution head in the hopper, and he added a removable partition, so he can put in one he can separate the wheat and the faba bean, And he also modifies the chutes so that one compartment of the hopper fed the front disc, and so for example for deep seeding the faba bean, and the other chutes fed the rear disc, so for a shallow seeding of the wheat. Another example is a farmer who tinker and combined tools to sow two species in one pass at different depths. So it was for a rapeseed faba bean mix. So what he did is that he combined a strip till, and he asked the manufacturer to modify it and to add a distribution heads, so he can sow the rapeseed while strip tilling. So he can sow the faba bean at the depth of 10 centimeter while preparing the seed bed for sowing the rapeseed with a precision drill with the field cultivator in red. And the last example is the farmer that construct a seed drill to sow species mixtures in one pass at different depths or at the same depth. So he combined a compartmented hopper with a field cultivator, and the field cultivator has two distribution heads, and he can sow a broadcast or in depth. So for example, for the mixed barley clover alfalfa, he puts barley in one compartment and clover alfalfa in the other. So barley is sent to distribution head to be sown in depth, and the mixed clover alfalfa in the other distribution head to be sown broadcast. And the other possibility is that he puts so in one compartment wheat and in the other faba bean, for example, and the two species are sent in the same distribution head to be sown in depth, so in the same row at the same depth. I hope it's clear. And then Adrien, the last results.
So what we show is that there is three logic for shaping the farm machinery to appropriate species mixture over the long term. First, there's a logic we called the frugal design logic. So in this group, farmers make their mixture practice evolve by reconfiguring existing equipment, by reproposing adaptation and tool combination. And when they invest, these are limited investment through second-hand purchases, collective arrangement, or targeted self-provision. So on the right, a small illustration of the kinds of modification farmer can make. So it's a self-built seeder with a front mountain hopper on a 4 meters tine cultivator, adapted for a very specific way of sowing his species mixture, the direct seeding. So the second logic is the high capacity design logic. Here machinery systems are closely tailored to evolving cropping practices through substantial investment, especially in sorting. Farmers also invest heavily in specialized seeders. They are often new, wide, have multi-hopper, and sometimes are customized by the constructor, like in the example on the right. And finally, there is the flexible design logic to cultivate diversity of mixtures. So farmers in this group increase their sorting capacity little by little over the time. This helps them to increase farm autonomy and improve the economic valorization of their mixture. And on the seeding side, they invest only occasionally, but they make the equipment evolve through self-building and self-provision. So on the right, there is an illustration of seeders that is self-built, but with a new distribution system. This self-building makes it possible to sow relatively quickly with good precision, and it helps farmers to sow a diversity of mixtures. So what we did in these works is to characterize the practice of species mixture differently by looking at it through the lens of agro-equipment. This had not been done yet up to now, and we also enriched the view of equipment by going beyond just self-built machinery versus the purchase of very high-tech objects. And we also showed that there is a coevolution between the practice and the agro-equipment, and the result highlights the diversity of activity that enable change within equipment and provide a leverage point for supporting this change. Thank you.
Well, thank you very much, Esther, Adrien. So our last talk before discussion is Fanny and Margot.
Thank you, Laurent. So yes, to end this webinar before discussion, we wanted to share with you some concrete illustration that we observe in the project intercrop values. Yeah, so as it was mentioned in the introduction, one of the main goals of the Intercrop Values project was really to support concretely in different places the design of locally relevant agri-food chains. And what does it mean? It's that concretely in each co-innovation case study, there are various actors from field to fork that have worked together during 4 years to make emerge such agri-food value chain based on intercrops. And therefore, as presented by Céline before, they have experienced various barriers and challenges that are raised by these intercrops, but they also have developed some solution to overcome these barriers. So for this presentation, we will zoom into a free case study in the next slide. And they will give us 2 concrete examples of solutions that have been explored and designed around agro equipments. So the first example in the next slide that will be presented by Fanny is the one that is located in southwest France. This case study is managed by INRAE on one part and also by a local chamber of agriculture. And in this case study, there is a group of 10 organic farmers that want to implement a diversity of intercrops and for food production. And in this group, what is interesting for us is that they have collectively learned and gained experience, especially about sorting, and Fanny will develop that later. And the second example we will try to develop will be presented by Lene, and it's based on the example of 2 co-innovation case study in which innovative equipment for processing minor species was designed and then used by different actors in this co-innovation case study. So the first one is located in Germany, and in this co-innovation case study, the different actors are working on intercropping between wheat and with wheat, and they want to produce some bread for food consumption. And the second example we will use is the one located in Italy, where we have there a network of innovative farmers that are really working on various type of intercrops, and they want also to produce a different type or a range of different food products. So we have here some pictures. They produce flour, pasta, bread, etc. So we will use all that to give you insights on different innovation that have been developed around sorting and also processing. Fanny, I leave you the floor.
Thank you, Margot. So I will be presenting the first example in the southwest of France. So we had a series of questions which emerged in the group of farmers as to know how to use intercropping. So for instance, which species should be combined, how should they be sown? And like Laura mentioned at the start, one of the main challenges encountered by farmers was to know how they should be harvested and how should they be cleaned and separated. And within the group, we had a lot of diversity regarding the motivations and reasons
in the choice of the species. So some chose the mixtures to help grow legumes, others to limit weed, and others depending on the ability to easily sort the crops. And so for us, one of the main challenges in the group was to find a way to address the cleaning and sorting challenges with such diversity within the group of farmers and the mixtures tested. So the next slide, please. Thank you. So to address the sorting issues, we first encouraged farmers to try various intercrops directly on their fields. And the objective was twofold. The first one, to observe the behavior of the mixtures in real conditions. So do the chosen crops work well together or not? And the second one was to optimize different technical management choices. So do I use the necessary tools and methods to perform well? And after harvest, the farmers were able to experiment with cleaning and separation using their own equipment, allowing them to become a bit more acquainted with the machine settings. And we used the collective in a way to try to expand the exploration of possible methods for growing, harvesting, and sorting a diversity of mixtures, as the group has each farmer have their own equipments, which are different from one another. Thank you, Laura. In parallel, we also organized a training session on how to harvest and sort to limit breakage. And this allowed to share some, let's say, some common operational principles, and some key learnings emerged from it. So I will share a few of them with you. The first one was that cleaning actually begins at harvest. So depending on the setting of the machinery for the combine harvester, so the speed or the winds that you choose, you can largely impact the risk of breakage. And it's often dependent on millimetric adjustments, which is not easy to find. And there are other and a diversity of reasons as of why the grain breaks. So it could be because of the settings, because of the disease of the crops, because of the maturity of the crops, and so on. So it's indirectly dependent on the behavior of the varieties that you choose to grow together, and also it is weather dependent. So there are no unique and simple decisions regarding sorting, and it's essential to define beforehand what the desired final product you wish for. And the question behind this is, do I wish to separate fully the crops? And this will shape the objective of the cleaning operation, and thus the breakage tolerance threshold. So it's more a matter of different trade-offs that needs to be thought every year. Thank you, Laurent. And I have some example to show you. So to overcome this difficulty of harvesting and sorting, to limiting broken grains, one farmer was ambitious enough to think the other way around, to try a wheat chickpea intercrop without limiting breakage. So he sowed the two crops during winter. He harvested and sorted the two crops together. And he kind of set his acceptable threshold of breakage at around 10% of chickpea residues in the wheat. He milled the mixture with the two crops and the wheat and the broken chickpea, and gave some samples to his consumers from local markets, from which they made a diversity of recipes, like you can see in the pictures. And I think it's a nice example also to show that it can work. It's still very niche, but it's possible for farmer to develop this kind of value chain, because the farmer controls the whole value chain and is flexible in the threshold of legume in his wheat. And now Lene will present to you some other examples of innovative ways for processing species for intercropping.
Hello, everyone. Can you hear me correctly? Can you hear me correctly?
Yes, perfect.
Yeah.
Okay. So I would like to focus on two more examples, but rather focusing on on-farm food processing machinery that we have seen in Germany and also in Italy. So the first example here is the one in Germany, where the farmer actually was putting the whole value chain into his farm. So from intercropping to sorting and cleaning to milling and until bread making. So what he was experimenting at a small scale was, for example, the stone mills, which you can see on the left here. On the top left, you have a traditional stone mill that is actually built with a hopper, and then you have the two stones, one is fixed, one is rotating, and he actually adapted the space between them to use it for classical cereals, but also for buckwheat, millet, spelt, einkorn, rye or oat, and also for pulses such as fava beans, lentils, chickpeas, soybeans, and also green peas. And this is rather the most classical traditional model actually that was used there. On the bottom left, you can see also an adapted model of a stone mill, which was a lot used in France and developed in France, which is the Astrier stone mill, where you can have on top of that a spring between the two stones that are rotating, where you have a lot more management of the space and of the pressure of the stones on it. So these were also adapted for minor species, for the use of minor species. And as you can see, attached to that machine, you also have a sieving box, which was used to sieve the flour, which was used, and the aim of that farmer was to make bread of whole grain flour. So he was really very attached to that possibility to limit the sieving and to keep the bran and the germ of the grain. And to achieve that goal, when you look at the right part of the slide, we experimented with a disc mill, which is actually also used for the same types of species that you can use either as a pure species or as a species mixture. And this is a machine which is actually equipped with an impact cutting grinder, which breaks the grain in the gap between rotating grinding discs and the baffle plate. So you can see on the left, on the right bottom, these metallic discs that are rotating, and it's actually projecting back and forth the grains. And you obtain with this mechanism a very fine flour, and you do not need a sieving mechanism as you had for the stone mills, for example. So you really are sure of having the whole grain in it. And you can move to the next slide to see the example from Italy, where there was actually specifically the farmer, again, in the same configuration, intercropping, milling, and bread baking also. And he also used these Astrier stone mills, but at a lot larger scale. So he was about to have a capacity of 4 tons a day of production. So you can see here on the left 2 Astrier stone mills, which were actually used to produce flour from minor species such as chickpeas, lentils, and he was specifically focusing on old local wheat varieties, so soft and durum wheat, to produce pasta and bread. And this one was a particularity to have specifically a lot more large-scale volume shaking sifter that was attached to it. So this was actually a combination of a rather traditional stone mill mechanism and an industrial sifting mechanism. And on the right here, you can see the machine that he showed me in his baking factory, where he was specifically focusing on the proprieties of the specific flour from the old wheat varieties for the soft wheat to make bread. The specific thing about this is that the baking strength of that flour is only 50 to 80. And in industrial bakeries, they prefer flours with a baking strength of 200 to 400. And the industrial processing is using high temperature and fast mixing movement, which these ancient softweed flowers cannot withstand because the dough would tear and fail to rise properly. So it's very important for the volume development and the rise, which is quite challenging with this. And instead, these flowers require slow and gentle kneading, making the industrial methods unsuitable. So what this farmer used with that, the 10% about what the flour that he produced on the farm, he uses a vintage dough mixer, which you can see here, which was once common in Italy, in Italian bakeries before the 1960s. And this machine really literally mimics the slow folding motion of a baker's arms, gently working the dough from outside in and backwards, and preventing this way the dough from breaking. So this is quite a curious machine, actually, where they have these two arms and the rotating bowl at the same time. So it was really different from the spiral that you can see in industrial processes. So these were the two examples I additionally would like to share with you, and we can pass on to questions and discussions.
Well, thank you very much, Lynn, and all my colleagues for all this very interesting presentation. Now we have time for discussion, so you can put your question directly on the chat, or if very complex question, you can just ask for the microphone. Bogi and I will manage this question. We have one from Eric Just. Eric Just is a coordinator of the Intercrop Values project. He asks us, he says that, okay, we present a concrete example of machinery developed with farmers themselves, sometimes organized into cooperative. But he asks, what could be the role of mature agricultural machinery manufacturers in supporting development of intercropping in Europe? So do you want to answer to this question? I have some ideas, but perhaps can you give you the floor?
I can start.
Okay. Good.
So I think that the involvement of more major agricultural machinery manufacturers is important for scaling up practices of intercropping, because all we saw are very interesting examples, but at very local scale. And so if we really want to foster the adoption of intercropping at broader scale and bigger scale, we really need to involve such manufacturers. But in my opinion, as I presented, it's not enough to only involve manufacturers. We also need to improve the access to the machinery, because the issue with new machinery is that they are usually very expensive and that farmers cannot afford them. So it really must be coordinated with other actions to facilitate access to such machineries.
Perhaps one point is that it's the idea of the chicken and the egg. We want to start. If farmers have no machineries, they have to develop by themselves. If they have access to machinery, perhaps they will use it and then grow more specific mixture. I think for major companies, the business model is not to develop machinery specifically for intercropping. But at the same time, if we move for an agroecological transition of agricultural system with more diversification and not only space mixture diversity in species cultivated, perhaps major manufacturers will have to adapt, change a little bit the way they develop machinery. Perhaps smaller machinery or more flexible machineries, because what we saw in the example presented by Esther, Adrien, is that farmers, they want some kind of flexibility to adapt in a diversity of situation. And perhaps also machineries that are more easy to modify. I think perhaps this is could be one way to involve kind of major groups. Not hesitate to put questions. For us, it was very clear. We already answered to all of your questions. Yeah, Bogi, take the lead.
It was indeed very clear, and you did a great job of presenting a very complex topic in an accessible way. So thank you for that. I was very interested in maybe the methodology or your experience with doing research about farmers. It sounded like you spend a lot of time on farms, discussing with farmers, understanding their business and their lives. And I just wanted to hear, how was your general impression about that? How is it for researchers to work with farmers? How do those relationships develop and evolve over time? And how are their general impressions or motivations for taking up intercropping? Were there, I assume the ones you presented were of course open to it, but what were their main motivations for doing so, for doing things differently?
Who want to
I can
answer?
start
Yeah.
answering a lot of questions. I think the farmers we interviewed were very had a particular situation and were very motivated to grow and sort mixtures, especially with Adrien's work, because he worked on trajectory. So he interviewed farmers that were growing mixtures for like more than 10 years, I think. Adrien, it was no, it was
Yeah, the
10 years. I
motivation.
don't remember.
Yeah, the motivation to adopt the practice were very different in the group we interviewed. Sometimes the farmers were like in the way of transitioning to organic farming. Sometimes they adopt the practice for a very specific use, for instance, nitrogen for the soil. Sometimes that was just to sow a specific cover crop. Yeah, but what we showed in the like dynamic analysis is that there are diverse entries to this specific practice.
And also that the motivation can evolve over time because they are learning how to grow mixtures, and then the objectives and motivation can evolve also.
And maybe to add some feedback from the case studies from the Intercrop Value Project, what we've seen is that the farmers that we work with are really motivated, and most of them have already been doing intercropping for several years. So they haven't been waiting to have the perfect equipment and so on, but it's often the same profile of actors. They're organic farmers, small scale, short value chain farmers. And so they've adopted the practice with what they have and making small adaptations like we've seen. But sometimes they don't do any adaptation. It's the case in the southwest of France. We've seen some farmers that are well equipped up to the optical sortings, but some are not, and so they just do it. And I think to upscale the practice, yeah, like Céline mentioned, there really need to be some optimization of how they do it and some investments.
Thank you for your answers. We have a question from Daniele Cavalli. Okay, I'm sorry if I didn't pronounce well. Asking if we think this is a question for Esther and Adrien. Did you find some example of integrating site-specific nitrogen application with sowing? So, for example, a way to apply nitrogen only to wheat. Did you know some farmers who want to develop this?
No, I didn't see it, but maybe Adrien, you saw it. I don't know.
You have your microphone shut down, Adrien.
I think one of the farmers that belongs to the second logic of, if you remember, of designing their agro machinery system, had a specific seeder with nitrogen application for a specific row, but that was the only example.
And I think perhaps in an example printed by Esther, if there is a partitioning hopper, you can put fertilizer in one of the partition and put that directly on the line of sowing. And perhaps also most of the farmers you interview were in organic farming, no?
Yes.
And so
Yes,
this
only
question
2
of
hectares
nitrogen
from-
fertilization was not so, it's not important. It's important for them, but they cannot use a mineral nitrogen. So perhaps this is why we didn't find such example. There is a question to Lynn, Fanny, Margot, Celine. Presented a very interesting example of the use of intercropping from field to fork, but at a small scale. And such like the question of Eric, how to scaling up and to make this kind of approach to food industry.
I can maybe start. So in fact, this question of scale up is really the big issue, and it's really difficult to apprehend. I think it all comes back to this idea of what is the future vision we have for intercropping and how do we want to develop intercropping. For scaling up, according to me and according to the results that we have, the easiest way is really to invest in sorting as much as possible so that crops coming from intercropping could be dealt with as crops coming from pure crops. And so you can just go into the existing value chains. You don't need to invest as much in new, more flexible processing machinery, for example, to adapt to different levels of impurities and so on. So it's kind of the, I would say, easy way because it doesn't question the standardization that we currently have. It doesn't question the main paradigms of the current system. But if you want to maybe invest a bit less in sorting and release a bit of tension from farmers and from collectors and valorize a bit more the impurities, then the actions to undertake the scale up will be much more different, and we will need to act on much more different points of the system and to involve much more the food processors in the development also of food processing machinery that are more flexible. As you said just earlier about machinery and agri-equipment, we could do that also in processing. But it's a different strategies, and we need to involve different actors and to distribute the resources differently. So it's also a choice to be made, and maybe the choice will depend also on scale and on the regions that are tackled.
Yeah,
And
maybe
there is, well,
if I can
sorry,
just,
Margot,
yeah.
just to know for your, there is another question that is linked with that, so you can complete it. Saying because inspiration is so tricky, perhaps one way is to use directly a grain mixture into food industry. Perhaps this is also a way to scale up. So go ahead for the answer.
Yeah, it was explored, I think, in some of the case study, but maybe Margot, Fanny, you can think about that. But the issue, as it's said in the question, is the question of the variability in the impurity level, because you can have different types of intercropping. You have, and as we don't know yet really how intercrop will react in the field, sometimes the proportion of the two crops will vary, the level of impurities will vary, the type of impurities will vary. And so this is very complex to deal with for industries. And there are also some quite strict labeling requirements. So they really need to say how much percentage there are of different impurities. So industrial are quite blocks with this kind of regulations also. So there are also some work to do at the political level to make this regulation more flexible regarding intercropping products.
Margot, sorry, I cut you.
No problem. Maybe Fanny, you can react on this question of mixed flour. But my point was also to talk about a little bit about the consumers, also to make the food industry moving. I think now the way that the innovation is built, I think that food industries have the potential to change things if there is a demand. This is the way that the system is functioning now. So I think that also in the project Intercrop Value, we have addressed this question of consumers and how we can also make them aware of the benefits of this practice and to make them more able to pay and to consume such products, also with a mixed flour, even directly from field, or also produce that are also enriched with protein. So I think it's also an interesting lever to try to make the food industry changing. But I will stop that because I see that we have other questions also.
And I think there, yeah, but I think there's a webinar specifically on food. Bogi, tell me if I'm wrong, but yeah, I'm sure we can discuss further on this topic. Yeah.
Yes, we will have a webinar on March 2 on processing and different ways of processing cereals mixed with legumes and what kind of products we can create from that. So be sure to tune into that too.
Thank you. We have here another question from Castro Alves Francisco. So asking what action or tool could be applied to improve farmer access to knowledge and machinery innovation? I think part of the answer is on the output of the project, but because Esther and Adrien, if I remember well, you went also on social networks and you discover that farmers are very involved. So perhaps as a researcher, we have to jump into the social networks to meet farmers and make a better connection with them. So I don't know. What do you think? Adrien, Esther?
Sorry, yes, and I think also that we went to see farmers that were very interested in species mixtures and that had that were farmers that also had the skills, time, and knowledge to tinker, modify their equipment, but it is not the case of every farmers. I saw also farmers that just had repurposed some equipment like a spreader fertilizer to sow small seeds, for example, alfalfa or clover. But like I think there's a lot of knowledge, yes, as Laurent said, on the social media, etc. But the farmers need also time and sometimes money to repurpose, modify their equipment, and not all farmers had time. I don't know if it's clear, but Adrien, if you want to complete.
Like the group that we interviewed also practiced crop mixture for years. So maybe we lack information on farmers that like stopped crop mixtures for different reasons that we didn't like study in this work, and it would be interesting like to conduct also other study on these farmers who stopped like crop mixtures.
Thank you. There's one to complete this. We switch to the next question. Well, the next question, perhaps Fanny, you will have some information to share, and I can also include. It's a question from Paul Kenny asking, intercropping or sometimes applied season specific in some of his work site, and he asking how to replenish soil health quickly when we are in a short crop rotation like wheat maize crop. So I say that, Fanny, I know that in groups, soil health was a question of farmers. My point of view as an agronomist is that crop mixture are only one way to help in improving soil health, but if we have very short rotation, it's using multi-services cover crops that will not be harvested, so to introduce more organic matter in the soil, also add manure, compost in order to improve soil organic content and soil health. And I think intercropping could help a little bit, but definitely is not sufficient if we want to improve soil health. Perhaps, Fanny, you have some information regarding what farmers think about soil health regarding intercropping in your group.
Yeah, I think it's basically what you just said. They don't use intercropping every year on the same plot, so the effect is very limited, I would say. And I think there would be a webinar on this shortly also, with more people that are more experts on the subject than myself. But basically what the farmers are also very interested about is what is the impact of the practice on their soil. And I think, and it's also maybe linked to the question right after, what tools to improve farmers' access to knowledge. And so basically in the project, we've been working with farmers, but also researchers and development organization. And I think it's a triptych that works quite well in order to produce knowledge on what farmers might lack today. And so I think it's one of the ways to work together is throughout this kind of project where we can make sure that the research and development organization and the field also meet. And so regarding soil health, it's been one of the main questions for our cakes. So we might have better insights at the end of the project on this. But I invite you to come to the webinar specifically on this topic.
Yeah, and Eric just had a comment in the chat saying, intercropping is not the solution to improve soil health. It could just participate as a small brick in the wall. And I think we can go a little bit further. Intercropping is not the solution to all the issues that agriculture is facing now. It's only one brick that can be used and adapted according to the goals and constraints that we have. I think we are on time and running out of questions. So,
and maybe just to add link back to the question on food industry, what I understood is that maybe if we're able to bring some more specific scientific knowledge on the impact of intercropping on soil health, then maybe it's an incentive for food industries to be also interested to support the practice.
And I saw that we have another question asking about intercropping in fruit tree orchards and equipment. I think it's not a question we have addressed because we focus on large crops. So I think there is orchard mixtures, species mixtures in orchard, mixing apple trees and pear trees. And I don't know if there is specific equipment for such production, unfortunately. It's not a question we have addressed, but perhaps my colleagues have information that I don't have. No, I'm sorry for that, Asia Calaras. Bogi, perhaps you want to conclude and...
Sure. Well, thank you very much, everyone, for being here. It was really great and successful webinar with a lot of participants. Very pleased to see that intercropping generates so much interest. And thank you again for all of our speakers. You spoke very eloquently and amazingly about the complex details of this topic. So thank you for that. Please be sure to stay in touch on our website and social media. There will be a lot of interesting results coming out in different formats: research reports, deliverables, brochures, policy briefs, practice abstracts, events, what you wish. So there will be a lot more still to come from the project. And as well, the 2 remaining webinars, I dropped the registration links in the chat, and you can also use the QR code from the slide. So I hope to see many of you there. as well. And until next time, thank you very much and have a nice day.
Thank you, everyone. Thank you, colleagues, for your very nice presentation. And as I say, Eric, intercropping is one brick in the wall of agroecological transition. And I think it's a big brick, but not the only one. Thank you very much.
Thank you.
Thank you,
Bye.
everyone.
Thank you.